Alrighty, we're going to go over the chapter for pre-AP FRQ and multiple choice right now. So just follow along if you weren't able to get these without this video. So suppose that there's an angle theta in standard position such that the sine of theta is -3/5 and that there's this other separate angle that has a radian measure of -4π/5. Answer the following questions. So the first one says, in what quadrants could theta terminate? Explain your reasoning. So sine of theta is -3/5. So theta could terminate in quadrants 3 or 4, since sine goes with the y value and y values are negative in quadrants 3 and 4. Okay, so that's part A. Next, if the angle is also such that the secant of the angle is less than 0, find the values of tangent theta and cotangent theta, draw and label the reference triangle. Okay, so for this right here, a couple of things you need to be aware of is that secant is cosine's reciprocal, and cosine goes with x, so this is really saying the x values are negative because anything less than 0 is negative. So this is telling us, if we look at the reference triangle, this is telling us that our original options with sine of theta equal to -3/5 is that we were in either quadrant 3 or quadrant 4, but since the x values are also negative, x values are not negative in quadrant 4. They're only negative in quadrant 3, and this is saying that we have the y over r, or if you prefer, opposite over hypotenuse. So who knows exactly where this triangle is, but we know that this measure is -3 and this measure is is 5. And this is the reference angle, theta prime, right in there. They're not asking us to find theta prime, they're asking us to find tangent theta and cotangent theta. So in order to find tangent theta is y over x, and as you can see, we don't have the x part of the triangle. So a quick x squared plus y squared equals r squared, or if you prefer, a squared plus b squared equals c squared. It's just the Pythagorean theorem. So we're looking for x squared, and all that will come out that r is going to be, sorry, not r, it's going to be x is 4 plus or minus 4. And since we're in the negative x direction, this is -4. So it's always good to look at it like this. Like if that tip of the triangle was a point, it would be -4, -3. So the tangent of theta is going to be equal to the y coordinate over the x coordinate, -3 over -4, which is 3/4. And that means that the cotangent of theta is just the reciprocal of that, which is 4/3. Not too bad. Okay, next we have C. In what quadrant does the angle alpha terminate? So now we're referencing this other angle up here. So they tell us that alpha equals -4π/5. So where does that terminate? So remember, negative angles go clockwise. If we were to cut that bottom half into 5 equal pieces, it would go to the fourth one. So it's right there. So we would write alpha terminates in quadrant 3 because negative angles go clockwise from 0, and it's almost to negative pi. Okay, and then part D says to find a positive coterminal angle. So remember, coterminal means coterminal, literally exactly what it says. It means ending in the same spot. And there's an infinite number of answers because we could go around the circle a bunch of times. But just looking at this graphically, I can start at the 0 and go counterclockwise and go to pi and then another pi. So that would be 1 1/5 of pi, which in improper fraction form is 6 pi over 5. So that's one way to find your coterminal answer. But the other way to do it, if you prefer a formula, is to just add 2 pi. Then we would need to get common denominators. So that one's 10 pi and negative 4 pi equals 6 pi over 5. So you can either do it visually or formulaically. Alrighty, next one is this guy right here. Consider the two angles theta and alpha to answer the questions that follow. The angle theta equals negative 10 pi over 3. So they're giving us an actual angle for theta this time. And then in the next one, alpha, we do not know, but we know the triangle that makes alpha. Okay, so express angle A in degree measure. So we have negative 10 pi over 3 times 180 over pi. That's the conversion. And draw it in standard position. So the pi's are going to cancel out. 3 goes into 3 once, 3 goes into 180 60 times, and 60 times negative 10 is negative 600 degrees. So in standard position, I'm going negative, so that's all the way to negative 360, negative 450, negative 540, and then, so this is negative 540, and this is negative 630, so it's, you know, right there. Okay, that was part A. Part B says, what is the measure of theta prime, which is the reference angle? So the reference angle is always made by the terminal side of your angle, which is right here, and the x-axis, which is right here. So we want to know this little piece right here. So if this is negative 630, that means that this is 30 degrees, because that's where negative 600 is, which means that this has to be 60 degrees since they add up together. This does say express it in radian measure, so you're more than welcome to put 60 degrees. Reference angles are always positive, even if the original angle is negative, so that's why it's not going to be a negative angle. So the answer for this one is pi over 3. For part C, this one says use theta, so we're still dealing with that same angle, is coterminal with which angle on the unit circle. Using the correct coordinates, find the exact values of tangent theta and cosecant theta. So it's coterminal with this angle right here. So if we did not go to negative, it would be coterminal with 2 pi over 3. Because if this reference angle is pi over 3, then that would be 2 pi over 3. But again, if you don't like using the graph to find a coterminal angle, then you would just do negative 10 pi over 3 plus 2 pi. You have to get common denominators. So then that gives me negative 4 pi over 3, which is still not positive. So I'm going to add another 2 pi over or another 2 pi, and then get common denominators. And so that's 6 and negative 4 now, which is 2 pi over 3. And then it said using the correct coordinates. So if I'm at 2 pi over 3, this is a better drawing than the last one I did. The reference angle is 60 degrees, or pi over 3, which we've already determined, which means that the coordinates are negative 1/2, comma root 3 over 2, because those are the side lengths of 30, 60, 90 triangles. And so it wants us to find tangent theta, which is going to be y over x. So the y coordinate over the x coordinate. We're going to copy dot flip, and this is going to simplify to negative root 3. And then the next one is what? It's cosecant theta, which is going to be r over y, because it's the reciprocal of sine. So the y value is root 3 over 2. So then we have to copy dot flip, and then rationalize, and we end up with 2 root 3 over 3. This one's positive because sine is positive in quadrant 2, and sine and cosecant are reciprocals of each other. Finally, D on this one, we get to the point where it says if cosine alpha is less than 0. So hopefully at this point you're able to realize that this means that the x values are negative. Then which has a greater value? The cosecant of alpha. So this is where you really have to be careful. The cosecant of alpha or the tangent of theta. And it says show your work. So we know that the cosecant of theta, which we just found, is 2 root 3 over 3. Okay, so we know that from the previous problem. The next one says that the sine of alpha is negative 3 over 7. So if alpha is negative, that would mean my triangle is either here. Sorry, if the sine of alpha is negative, that would mean that my triangle is either in one of these two quadrants. Just give me a second because I'm going to move the camera back. But I drew my triangles wrong. So I'm fixing that real quick before I do that. Okay, so if the sine of alpha is negative 3 over 7, these are the two possibilities, negative 3, 7, or negative 3, 7. But it does tell us that the cosine of alpha is negative. The cosine of this triangle over here would be positive because that quadrant is positive. So then what I need to do at this point, in order to determine if the tangent of alpha is greater than cosecant alpha, is figure out what this missing side is so I can do y over x. So that's just Pythagorean theorem. So that's going to be x squared plus negative 3 squared equals 7 squared. X squared plus 9 equals 49. X squared equals 40. Square root. That's 10 and 4. So that's going to be x equals negative 2 root 10 when you simplify the square root of 40. And I'm picking the negative case because it's on the negative side. And then tangent is y over x. So that's going to be equal to negative 3 over negative 2 root 10, which is going to change it to positive, and then I'm going to rationalize. So I end up with 3 root 10 over, this is getting rationalized, 20. And if you're not sure which one is bigger, the top of this PAP actually says that calculators are permitted. So you can grab a calculator and figure out which one is bigger. So we have 2 square root 3 divided by 3, which is about 1.155, and 3 square root 10 divided by 20 is 0.47. So I would definitely say that, I'm just going to write it over here, cosecant theta is greater than tangent alpha. Okay, so that's that one. Now I'm going to flip it over and do the last pre-AP before we do the multiple choice version. So I'm doing the last FRQ real quick. So this one says, suppose that there is an angle such that the secant of the angle makes this triangle right here. So we're in the trig chapter, so if you're ever not sure what to do, try and use the trig function to make a ratio. So the secant of theta is going with cosine, because that's cosine's reciprocal. So this is really r over x, but you can see that root 3 in there, which is going to mean that it does have a 30, 60, 90 component potentially. And then we also know that the tangent of alpha is -1. So let's see these questions. So in which quadrants could theta lie? Justify your reasoning. So we've already done this a couple of times, but we're just going to say that secant of theta can lie in quadrants 1 or 4, since it is cosine's reciprocal and cosine is positive. And since we'll actually talk about since cosine goes with x, let's see, and x is positive in Q1 and Q4, so will secant theta. Okay, so that was part A. Part B says find two values for theta. So they actually just want us to find this angle on the interval from 0 to 2 pi, show the analysis that leads to your conclusion. So secant theta equals 2 root 3 over 3. Therefore, cosine of theta is actually going to be 3 over 2 root 3. So this is important because you have one like this on your test. So you need to recognize the reciprocal relationship. So if I multiply both of these by root 3 over 3 to rationalize, I get 3 root 3 over 6, because this is 2 times 3, which actually simplifies to root 3 over 2. So that's really helpful, because that's telling me that the x-coordinate of the triangle is positive root 3 over 2. So again, that secant was r over x, so this is x over r. So where are the two places that the cosine is positive and has a x value of root 3 over 2? And that's going to happen in both of these triangles. So if I finish labeling all these, I have that. And then the answer to this says that it has to be over the interval from 0 to 2 pi. So right here, this angle right here, opposite 1/2, is 30 degrees. So that would be pi over 6. And then we need this same angle that starts here and goes all the way to here, which is going to be 11 pi over 6, because it's almost the full loop of 2 pi. Some of you may ask why we didn't just answer negative pi over 6 like we did with inverses. First of all, we're not restricted to just certain quadrants because this is not an inverse. They didn't give us the inverse to start, so there's actually two triangles. And second, it tells us at the top that they want the answers between 0 and 2 pi. Furthermore, the third thing is that cosine inverse is actually defined in quadrant 1 and 2. So because we're not dealing with inverses, that's not what they give us, then we can actually answer both these angles right here. Okay, part C says if the cosecant of alpha is less than 0, So I'm going to just go back up there and make sure you realize that the sine of alpha is negative. Which quadrant must alpha lie? Justify your reasoning. So the tangent of alpha equals -1. So alpha can be in quadrant 2 or quadrant 4, since that is where tangent is negative. If cosecant of alpha is also negative, then alpha must be in Q4, since cosecant alpha is only negative. In Q3 and Q4. And the two conditions overlap in Q4. Okay. And then part D asks us to find the value of alpha. So if we know it's going to be in quadrant 4, and we know that the tangent of alpha is -1, the only way that we're going to get a y over x ratio to equal -1 is if it's a 45-45 90 triangle. So this is -√2/2, that's √2/2, and that's 1. And then this says answer in radian and degree measure. So we're going to go like this and say that that is 7 pi over 4, or 315 degrees. If on this one you ended up writing negative pi over 4 or negative 45 degrees for this particular question, because they didn't say we had to answer over the interval from 0 to 2 pi, those would be acceptable as well, since they're coterminal with 7 pi over 4. Okay, now we're moving on to the multiple choice. So this right here should be a degree symbol. It copied funky. It says the angle -456 terminates in which quadrant. So we're going to go -360, -450, and then it's just a sliver into this quadrant. So that would be quadrant 3. Sure you can get that one. The terminal side of an angle lays on the negative y-axis. So that means it lies here. Which of the following angles could be the measure of the angle described? Negative 9 pi over 2. So that's like, what is that? Negative 4.5. So we would go 1, 2, 3, 4, 5, so that one works. Negative 5 pi is going to end up 1, 2, 3, 4, 5 here, and 6 pi is going to end up here, so it's not these guys, so it's just going to be A. Next one, find the exact value of the sine inverse of -√3/2. Okay, y value, negative, that's a 30, 60, 90 triangle. So we have two options. We can either be here or we can be here. It does say sine inverse, and sine inverse is only defined in quadrant 1 and quadrant 4 because that's where the graph passes the horizontal line test. So it's going to be here. This is a 60-degree angle. They want us to answer all inverse questions dealing with sine over the interval from negative pi over 2 to pi over 2. So even though this one is 5 pi over 3, we're just going to answer negative pi over 3. So it is C. The next one says find the point on the unit circle that corresponds to this angle. So we're just going to graph that angle. Negative 5 pi over 6 is here. That means that this is a 30 degree or pi over 6 reference angle. So that's negative 1/2, and that's negative root 3 over 2. So negative root 3 over 2, comma negative 1/2. They should both be negative, so that would be A. Okay, moving on. If cotangent theta and sine theta, if cotangent theta is greater than 0, all students take calculus. That means it's positive, so it's in those two quadrants, and the sine of theta is negative, which happens here and here, then that is going to be in quadrant 3. Alright, next one, the terminal side of an angle terminates in quadrant 3. Which of the following trigonometric ratios are negative? All students take calculus. It's ending up here. Sine is negative, cosine is negative, and secant is negative. So that's 1, 2, and 4. Which of the following angles is coterminal with negative 7 pi over 6? So negative 7 pi over 6 is right here. So which ones end up in that same spot? So 6 goes into 17, 6, 12, 2 and 5, 6 of pi. So if I were to graph that one, there's 2 pi and 5, 6 of pi. Ooh, the first one worked. It's coterminal. You could also do the formula, but I'm not going to. Last problem says, which of the reference angles in degrees represents the reference angle for this? So 3 pi over 5 is right here. So this was the 3 part, so this is the 2 part. So that's 2 pi over 5 is the reference angle, but we want it in degrees, so we're going to do pi over 180. And then 5 goes into 5 once, and 5 goes into 18 3 times with 3 left over, so that's 36. 2 times 36 is 72 degrees. Alright, that's it.